Stop focusing on just personal protective equipment. Good afternoon. I'm Anthony Kapkin, editor of Electrical Business Magazine, and welcome to the webinar, Best Practices in the Design Phase, which specifically focuses on electrical safety by design, not chasing safety afterward. After all, why not make your electrical systems and workplaces inherently safer? It's great to see we have a huge variety of registrants, from public utilities and consulting engineers to the contracting community. Welcome to all of you. I also want to thank i-Gard for bringing you today's presentation. Thought leaders on electrical safety, i-Gard's core competence is in the application of high-resistance grounding technology in combination with a product portfolio that helps customers reduce arc flash hazards. Please be sure to reach out to them to learn how to make your people and places inherently safer. Visit i-gard.com. Now, today's speaker, our Electrical Safety 360 columnist Mike Doherty, is a subject matter expert known throughout electrical safety circles. Mike has been the chair of the technical committee for CSA Z1002 Workplace Electrical Safety since its inception in 2006 and has been the official liaison between CSA in Canada and NFPA in the States from 2006 until 2015. Now, there will be time after the presentation for Q&A. Just type your questions into the questions window, not chat, in your webinar control panel. Now, please welcome Mike Doherty. Mike, over to you.
Thanks very much, Anthony. First off, I just want to welcome everybody to the webinar this afternoon. It is a topic of great interest to myself, certainly the whole risk assessment piece and how we're going to weave it into the design phase. And I always tend to focus on the family. That's what that little picture is about. It's about getting home at the end of the day to make sure we can look after our families. So, title, Electrical Safety by Design, Not Chasing Safety Afterward. We do spend an awful lot of time focusing on PPE. It is critical. Last line of defense, we're going to talk about that hierarchy of methods, but what we really want to think about today is following best practices at the design phase, and that can weave through a lot of many different thoughts, and we'll try to touch on some of them today. And as Anthony mentioned, a special thank you to i-Gard. Certainly I know they are very, very committed to electrical safety. So safe workplaces do start with the ins and outs of risk assessment, and that's something we really focused on in CSA Z1002, which is the Workplace Electrical Safety Standard of Canada for that sector, and really thinking about how you can use risk assessment in your work practices and every day. There's a little bit of information there if you want about myself if you want to look at it in your future peeks at this webinar. So today's agenda, we're going to have a short introduction. I want to talk about CSA standards, a general overview, and the alignment we have here in Canada, which, in my opinion, no one else on the globe has anything like it. I want to have a peek at CSA Z1002, which has a very long title, but I just call it the Risk Assessment Standard of Canada. We'll have a little look at that. And then I want to dig deeper into CSA Z462, the 2015 version, and many things we could look at, but I want to look at how it's aligned with best practices in the design phase. And when you dig a little deeper into Z462, you'll find that risk assessment alignment in best practices in design can be found in Annex O and in Annex U, Human Performance. And the whole thing, in my opinion, is about getting ROI. What's your return on investment? What's your return on investment for getting your workers home safe, for also having great financial excellence in your place of business? Both of those things, in that order, are the way they need to go. So real quick, what are the what's, the where's, the when's in regards to risk assessment? And we really have embedded that in the CSA Z462. And just a little bit of interaction, mostly between myself, but you will get to ask questions at the end. You can always contact me after if you've got any questions at all. And certainly, I hope there would be some questions. That means you were listening and we got some thoughts going. Same thing with i-Gard. If you've got any heavy questions you want to ask them, you can contact anybody, certainly going forward. One of the things I always mention, I said I don't call it electricity when it comes to workers. It's toxic energy. It is one of the most toxic substances that a worker can interact with, whether it's direct contact touch potentials, whether it's arc flash energies. It is a very toxic thing. There are no MSDS sheets for electricity. When you have a look at those overhead power lines on your way home tonight, just think about how much energy is up there, and then all that energy coming into our plants, and certainly at lower levels in our homes and that kind of thing. One of my favorite sayings is, good safety is good business. You want to make a lot of money, don't get hurt. You want to go home the end of the day, don't get hurt. So good safety is good business. You need a map, you need a plan. Job planning is very, very significant, and it's got to happen up front, whether it's done in the design phase or whether it's done in the work practices. You've got to have trained, competent people. So CSA Standards General Overview, and why I think it's so important and such a great lead into this design discussion. There are many standards kicking around out there. You'll see up at the top, OH&S 18001 for a BSI, British Standards Institute. They're about to come up with a whole new one and may eat a lot of these up. As far as safety management in Canada, the equivalent of 18001 is CSA Z1000, Safety Managed Systems. It's not about the safety, it's how you manage your safety. ANSI Z10 in the US, Occupational Health and Safety Management. So Z10, 18001, Z1000, all very similar, a couple of differences. Your company safety managed system could use any one of these three. You got to pick one. And of course, many of the VPs and presidents understand 14001, 9001, be it environmental or quality. It's the same Plan, Do, Check, Act template, which is very, very good. In Canada, we have that unique system, and we've got CSA Z1000, Health and Safety Managed Systems, and we have all the aligned systems underneath. Of course, CSA Z462, Workplace Electrical Safety. We've got a guideline, CSA Z463, Maintenance of Workplace Electrical Systems, which does tie back into Z462. We've got CSA Z1001. What's your standards for training? And this is the one that I find to be so fascinating, and the one that we benchmarked on our technical committee on Z462. Big, long title, Occupational Health and Safety, Hazard Identification and Elimination and Risk Assessment and Control. Again, I just call it the Risk Assessment Standard, but it is very, very good, as we'll see. And of course, Z1005, Incident Investigation and Prevention is being worked on as we speak. CSA Z1002. There's that big title again. It's something that is really, really world-class, leading-edge stuff. And this is right from a screenshot. You can go down into CSA and purchase any of these standards if you care to. They're very, very good. And I'm not going to try not to read all these words, but I'm going to have a quick peek at it. And it says, there currently exist over 100 risk assessment models across legislations in standards and in guidance documents with confusing terminology. That can lead us to misunderstand or misinterpreted information being used to make critical organizations decisions regarding risk tolerance. Z1002 helps to bring clarity by focusing on worker protections through hazard identification, control, and elimination where possible. And we'll see in the hierarchy of methods, which is step 3 in risk assessment, how design can work so strongly back into that piece. It also applies to organizations of any size and could be applied to all stages in the life cycle of a product, process, or service. And it focuses on hazards that can be eliminated, as well as control of those that cannot be eliminated. And of course, in the hierarchy of methods, which we'll see, it's elimination by design. And rarely does the word by design end up right after elimination, and truly it should, as we'll see. So the 3 steps from CSA Z1002 risk assessment standard are as follows. It's to identify the hazards, and of course in our Z462, so it's identifying electrical hazards. Step 2, assess the risks. Step 3, implement the risk control according to a hierarchy of methods as per current best case practices, due diligence standards. It could be your work instructions. So really from Z1002, it stops after the hierarchy of methods, but when you start thinking about what you're actually going to do in a practical sense, you got to get down to your work instructions or your work procedures in your place of business. I'm big on benchmarking. I was in the nuclear power 31 years. We really put a lot of time and thought and effort into best practices, and we were told we needed the benchmark. So what we did on our, you can see over on the right-hand side, that's a copy of the cover of a workplace electrical safety standard, CSA Z462-15. We have a wonderful technical committee of great experts right across Canada from BC to Newfoundland. And what we did is we benchmarked CSA Z1002 We love the risk assessment procedure. We've added new definitions in the definition section of Z462 in regards to risk assessment, and they really are nicely aligned with the best case practice risk assessment standard. Jumping into Z462 then, and it's a very small sliver. There are many things we could speak to in Z462, but today, of course, we're trying to look at risk assessment alignment with best practices in the design phase. And again, we're going to look at Annex O, Annex U, and with me, it's all about, as I said, return on investment. And we're going to see what are some of the concepts for return on investment from a design perspective. I always use this slide when I'm doing training or consulting. People will take a paragraph or a sentence or a page out of Z462 or out of any of the other good standards that are kicking around, and they'll say, well, it doesn't work in my workplace. What you'll find is if you use Z462 in its entirety, it's a systematic approach. Very important to look at, and you'll usually find that things are reasonably well answered if you look at it in the standard as a system. So keep that in mind. This is also one of the things I like to talk about. This is not really about risk assessment. It's about how you manage risk assessment in the electrical sector. The steps. Identify the hazards. That's something you really need to do, and you need to do it at a high level. You need to assess the risks, and you need to implement a risk control according to a hierarchy of methods. Those are the 3 steps right from Z1002, which we have embedded as a best practice based on our benchmarking in CSA Z462. So the risk assessment procedure itself, again, identifying hazards, and people say all the time, whether electricians, whether linemen, managers in the electrical sector, supervisors, and we say, well, identify the hazards, and they say it's 600 volts, or it's 13.8, or it's 4160, and they leave it at that. Well, you have to put a little more thought into it, in my strong opinion. If you look at it, there are touch potentials. There can be touch potentials, certainly with your hands, maybe other parts of your body. There can be low voltage, medium voltage, high voltage. They all can affect you at a different level, of course. There are step potentials. If you unfortunately were to knock a hydro pole down on the way home tonight from work with your vehicle, you might be introduced to step potentials at a very high level as that toxic energy flows into the resistor some people call the dirt or the ground, and the distance between your feet can be enough potential difference to stop your heart or worse. Certainly flashover in the high voltage world. The lineman, you start working 125, 250 kV, flashover can be a huge detail. You don't really need to even touch it. And then of course arc flash, arc blast. Some people make the mistake of calling Z462 the arc flash standard. It's not. It is a shock and arc flash as part of the whole standard. And of course there's heat, radiant and convective heat. You can get dB to your ears. There can be shrapnel, superheated noxious hot metal vapor. There could be infrared UV light, certainly pressure, and there could be molten copper flying. Though when I'm talking about electrical hazard identification, I like to break it down a bit more. It will change the way you plan your work, and in the design phase, if you think about hazards at this level, it might change the way you design the equipment and the equipment that you put in your plant and that you retrofit your plant, and it makes a big difference, in my opinion. So assessing risks, what does that mean? Well, from the standard, some of the, and certainly you know your plant or your equipment the best, but these are kind of the overview ones. What's the age of your equipment? If it's, and some of this stuff is lasts a long time. Could be 45, 60, some of the places have been 100 years old and the equipment just sits there and works. The age of the equipment is a risk-based question. The hazards, be it the electrical, touch, arc flash, arc blast type hazards, are what they are, but when you assess the risks, this is where your qualified managers, qualified people, and electricians, linemen, whatever, they know how to answer these questions on your equipment better than anybody. So what's the age of the equipment? That's risk. Who's the manufacturer? As we know, there are outstanding manufacturers and there are weak manufacturers. Based on the equipment that you have or you're considering getting, that manufacturer is going to be a risk-based question. What's the condition and appearance of the equipment? If you do maintenance, if you use CSA Z1002, a maintenance guideline, and you do it to proper intervals of time, and you keep it clean, and you keep it maintained, and you keep it lubricated correctly, that is going to be much less risk than there is in a plant where you just let it go, and let it go, and let it go. The environment, some places are really the dust, the dirt, the water, all those things. The operating history, of course. Do you have the documents? Are you, if you tell me you maintain your equipment, show me your documents. If I don't see them, and of course that comes into the maintenance history. What's the configuration of your power system? In the big power plants where I worked, you could switch all over. You can odd, even buses, tie breakers. All kinds of things will change the configuration of your power system. It'll change your short circuit current values. It'll change your arc flash values. And then how's the equipment being used? Are you running it to fail? Many, many questions. These are all risk-based questions which will affect the safety and certainly the production capabilities of your place of business. So implementing the risk, and this is the third step from CSA Z1002, but it does have major impact back to the electrical part, which is what we tried to do in our Z462 committee. This is one of the standard ones. Use this many times. You'll see the Z462 and the NFPA 70E up here. You'll see the ANSI standards and the hazard control measures. You get this slide. Probably should be updated. It should say risk assessment measures. But it's an older slide, but it still does point out very well. And what you'll see on the far right is PPE, and as most of us know, PPE is the least effective method in the hierarchy of methods, but it's also mandatory. When all these other things fail, it's your last line of defense, as we always say, and it needs to be done. It must be done. Sometimes we spend too much time there. The administrative controls, training, warning signs, all these pieces, and a lot of these are addressed in CSA Z462 or 70E. Where you do need to start thinking about our engineering controls. What are the designs for engineering controls? How do you substitute better equipment? And elimination is always the word that's there, and that's where I have a bit of a bone to pick. It should say elimination by design, and it rarely does. Almost everybody I know will say, oh, elimination, that's lockout tagout, and it's not. This section here, which is very, very robust and the most effective, is elimination by design. It was never meant to be lockout tagout or utility work protection code if you happen to be in the high voltage IHSA USA world. We used to be USA. And IEEE color books, all those things. So, and of course, ANSI Z10 in the States or CSA Z1000 or OH&S 18001 provide a framework and a foundation for all those things. And it really should say down here, this is a little old, should say risk assessment measures. This is another one, exactly the same thing. It's just got a couple little tweaks. What you'll see on the left-hand side is the control effectiveness we just talked about. What you'll see on the right-hand side, which is critical, are what's the financial value? Of course, we don't want people to get hurt, but we need to make a profit. We need to work in a business where it is viable, and you do have a little bit more money to put in great design equipment and train your people, and so you need to make a living. You'll see PPEs available, effective, easy to use. The engineering controls, and it says design in the engineering controls to minimize risk. Absolutely correct. Go up a little bit further, substitution of less hazardous materials, and again, this should say elimination by design. Eliminate the hazard during a design or redesign. That's a really, really strong method to reduce the risks in your place of business. So the risk control hierarchy methods, again, elimination by design. I added the by design. All you'll ever see is elimination typically, and it's the effectiveness structure. Most places, a lot of these things come into vogue, and we do spend an awful lot of time on PPE, which we should. It's never in place for many years, but certainly we could do a lot more as we go up if we're trying to get good return on investment for the dollar spent. So this is a screenshot with a couple of extra little pieces that I put in. It's a screenshot right from CSA Z 462, Workplace Electrical Safety, 2015. You will notice the little triangle here. Anywhere you see a triangle in a CSA standard, that means it's something new. So you won't see for clause 4.1.5.7 risk assessment procedure, which we took from CSA Z1002 because we didn't want to reinvent the wheel. We want to be aligned with best practices. And it says the electrical safety program shall include a risk assessment procedure that addresses worker exposure to electrical hazards. That procedure shall identify the process to be used by a worker before work is started to carry out the following, which we've already touched on a few times already. Identify the hazards, assess the risks, implement risk control according to a hierarchy of methods. And the notes right in, and this is exactly from Z462, I have put the red underlined sections. The hierarchy of risk control identified in CSA Z1002 is as follows: eliminating the hazard, substituting other materials, processes, or equipment, engineering controls, systems that increase awareness of administrative controls, which are, for example, training, procedures, instructions, scheduling, great job planning, really, and lastly, PPE, including measures to ensure its appropriate selection, use, and maintenance. I would suggest to you strongly that the measures to ensure that the PPE is used correctly is a design. You need to have a design of your PPE program in place. You need to have a design for the equipment you put in place, and of course eliminating a hazard should have said by design up on portion A. There's a big risk assessment procedure in Annex F, which we're actually going to be paring down. It's almost a PhD dissertation presently. It's about 8 pages. It's fabulous if you like that stuff. We're going to make it a little simpler, a little more effective for 2018, January, when the next one comes out. That risk assessment procedure may include identifying situations where more than one person is required to be part of the process, as well as training and equipment that could be provided to evaluators. You need to evaluate a risk assessment procedure before you install new equipment. You need to provide evaluators to do risk assessment procedure if you're going to retrofit your plant. And in the design phase is when you can really, really be effective. Just exactly what it says in Z1002. So you can see here on the top portion, the CSA Z1002 is a risk assessment procedure general. And it's not just electrical. It can be used mechanical, chemical, working at heights, anything. Those 3 steps, in my view, work for any hazard in a workplace. We, in Z462, have taken that concept. We have a shock risk assessment procedure in the standard. Supplemental to that, or not supplemental to it, but in parallel to it, there's an arc flash risk assessment procedure, and you can use that for if you're going to use a table method from Z462, or if you're going to use the incident energy analysis method. So the arc flash risk assessment splits into 2, but it's all based on definitions, best practices from Z1002. So there's great alignment between these standards, which to me is world-class benchmarking and world-class standard. As I've said, design is the #1 most effective, as noted in CSA Z462, Annex O, which is an annex on safety-related design, which is on page 52 of Z462, which we're going to have a peek at. So again, the same thing. You'll see Annex O, safety-related design. I highly recommend that you go have a peek at it. It's only a couple pages. If you're trying to make a business case in your place of business to possibly bump up, install new equipment, or to bump up the equipment that you have, it's outdated, needs to be changed, really think about using the design principles and effective, because you're going to have to make a business case if you're going to spend a bit more money. And you might find that in 5 to 10 to 15 years you've paid for itself, even if there are no electrical incidents in your place of business. So let's have a look at Annex O, safety-related design. And these are screenshots right from it. And again, you can see down on the bottom, if you want a copy of Z462, please go see the CSA. They happily get one to you, and of course there's a certain cost. So clause 0.1, the introduction. It's an annex that addresses the responsibilities, and these are important words. That's why I'm going to read them to you. This annex addresses the responsibilities of the facility owner, the facility manager, or the employer having the responsibility for facility ownership or operations management with regard to performing a risk assessment during the design of the electrical systems and installations. it's very, very clear. The people who own the facility need to be doing risk assessment when they're designing their plant, or if they're going to install new equipment. Very, very clear. And what I will relate to in a couple minutes, our friends in Europe, in the EU, have been doing this for years. As a matter of fact, they've made it mandatory by law, and that's the difference. And they've had great results by doing risk assessment in the design, and they have to do. They can't. It's not a nice to do. They must do, as we'll see with a couple of the examples I have a little bit later in our webinar. Clause 0.1.2. This annex covers worker safety related design for electrical equipment and installations in workplaces covered by the standard. This annex only discusses design choices that have an impact on the application of safety-related work practices. Z462 is a work practice standard. That's what it is. Our Canadian Electrical Code, the CEC, Part 1 is a design and installation standard. They work really nicely together, but they are a different scope of work. Clause 0.1.3. This annex does not discuss specific design requirements. The owner, manager, or employer specified in Clause 0.1.1 should choose design options that will eliminate hazards or reduce risks and enhance the effectiveness of the safety-related work practices. So what you need to do, kind of like we did on our Z462 committee, go out and benchmark. Find the best designers, the best equipment, the best companies that are going to give you some options that give you great ROI for the equipment you want to install, so you have safer work practices, you have safer workplaces, and you continue to provide a place where they can all work because you're not losing production based on electrical incidents. General design considerations. Facility owners, facility managers, employers responsible for the facilities and installations where electrical energy is a potential hazard to workers and other personnel should ensure that the electrical hazard risk assessment is performed during the design of the electrical systems and installations. Again, it's very clear. If you're trying to make a business case with the people that need to pay the bills, and they have huge accountability, and I get nothing but respect for that, there's a couple of clauses here that might help. And again, to me, this shouldn't say electrical hazard risk assessment. It should say electrical risk assessment. And it's one of the words I'd like to remove because it takes us back a little bit. We don't want to do that in our standard. So I've already mentioned to the committee, this is a word we might want to remove, trying to just call it risk assessment. Clause 0.2.2, and it speaks to clause 4.1.5.7 in our standard, should be used to compare design options and choices to facilitate design decisions that eliminate risk, reduce frequency of exposure, reduce the magnitude or severity of exposure, and enable achievement of an electrical safe work condition. Workers want to be in a place that says it's an electrical safe work condition. That's what they want. Nobody wants to get hurt, and we want to continue to push our production. And otherwise enhance the effectiveness of the safety-related work practices specified in the standard. Design option decisions should facilitate the ability to eliminate hazards or reduce risks by doing the following: reducing the likelihood of an exposure, reducing the magnitude or severity of an exposure, and enabling achievement of an electrical safe work condition. We're going to mention, and it's only about 2 more pages in Annex, so some of the classic ways by design that you can accomplish some of these things in A, B, and C. So incident energy reduction. These following methods have been proven to be effective in reducing incident energy, certainly calories per centimeter squared. Zone selective interlocking. A method allows 2 or more circuit breakers to communicate with each other so that a short circuit or ground fault will be cleared by the breaker closest to the fault with no intentional delay. As we know, the longer it takes, the more incident energy, heat can be applied to the fault area where the worker could be. Differential relaying, super fast relays on either side of a transformer, typically, and fast is good, slow is not good when you're talking about arc flash calculation. Energy reducing maintenance switching with a local status indicator is a wonderful way to reduce incident energies. And by the speed, you can put it in a maintenance position on the outside chance there is a mistake. We're going to touch on human performance a little bit in a few minutes. People do make mistakes. They do have bad days, and certainly a maintenance switch can reduce the severity and the likelihood of an incident. So it's good. Same with arc flash relays, looking at light. A few other in clause 0.2.4, other risk control methods, which lines up nicely with CSA Z1002 and Z462. Energy reducing active arc flash mitigation systems. It can reduce the arc duration by creating a low impedance current path located within a control compartment to cause the arcing fault to transfer to a new current path. In many, many ways, the engineers in certainly the last 10 years have really come up with some great design concepts and methods to make for a safer workplace and reduce the likelihood of events. Again, arc flash relays, and this is one, of course, we want to touch on today. High resistance grounding. It was something we used in our power plants. It was put in place by our electrical engineers in the design phase, and it was very, very effective. It made for a very important, it was much better for safety, and there was huge accountability in our power plants here in Ontario to ensure that we could keep the grid up and running. So it's about worker safety, it's about reliability, it's about applying the electricity you need, whether it's to the public and to businesses, or just in your own place to make sure that you can continue to run production. And current limiting devices. So all these things, if you ask a good engineer, what can you do, they can come up with some really, really good ideas that are effective and give you a good return. And this is just something I put together. I had a good chat with my good friend and colleague Sergio Pineda from i-Gard earlier today. We were just peeking at this slide, and he was saying there's so many questions you could ask about this slide, and that's correct. And if you have questions, please come and see me after. But for instance, what you'll see is a worker racking in a breaker, but you'll see, do up the bolts. If this thing lets go, there could be an awful lot of pressure depending on available short circuit current, which generally is aligned with the amount of pressure that could this door would blow right open. It could blow open depending on the level of the fault. One of the great engineering design things that could be put in place was in place in our power plants. All our 4160 13A switchgear was to a standard. EMAG G14-1 arc resistant switchgear assemblies. It made a much, and that comes under the engineering controls, and they benchmark best practices. It was a great idea, and we did have an incident in the very early 90s where a 13.8 breaker did blow up, and no one got hurt because it was arc resistant switchgear. So less worker likelihood of getting injured, and we didn't shut the whole plant down. It was just one breaker. So I really want you to think about what work practices are you going to have going forward? Can you put good electrical design in place to reduce the risks? And you have to do that in the risk assessment phase and the design phase. And just as another example, to reduce the likelihood of exposure with safety by design, high resistance grounding. A great majority of electrical faults are the phase to ground fault. They really are. Even in a 600 volt motor control center starter, often, certainly, for people who will use a non-insulated screwdriver, it goes single phase to ground. If it goes single phase to ground, it will often propagate, phase to phase to phase to ground, and it's a very significant arc flash, and people get hurt, and certainly on higher voltage equipment as well. But it's almost always starts as a phase to ground, often by an uninsulated tool. Our friends in the high voltage world, the linemen, have used insulated tools for a long time, and it's something that's just become far more important in the industrial commercial world, but there are still some that don't. High resistance grounding will insert an impedance or a resistance in the ground return path and will typically limit the fault current to 10 amps and below, and now that's at 5 kV normal or below. All those things are electrical parameters that would need to be discussed going forward in your place of business. But it would leave insufficient fault energy and thereby helping reduce the arc flash hazard levels, which is fabulous. High resistance grounding will not affect arc flash energies line to line or line to line arcs. Line to line to line, all three phases. So, but it is elimination by design. It is a great thing to think about, to have the very good risk assessment discussion while you're putting your plant in place, or if you're going to put a new lineup of switchgear, something you really need to think about. If you're not thinking about it, you're probably not being as effective as you could be. And why is this so important? Well, I had asked our technical committee just a couple of years ago because of my nuclear background, and the nuclear people really have this hammered. Annex U in Z462 is a human performance and workplace electrical safety annex. Safety-related design does impact it a little bit. As a matter of fact, our friends on NFPA 70E have not put this human performance annex in 2015, but to my understanding, I believe it's been accepted. They like it now. They've had a peek at it, and I believe NFPA 70E is going to take our CSA Z1002 Human Performance Annex and install it in NFPA 70E 2018. So, and ultimately, people make mistakes, so it's something to think about. And I'm just going to go right down to the bottom, but it talks about human performance, the hierarchy of risk control methods, and it's, again, eliminating the hazard, and it's in Annex U. To eliminate the hazard, the best place to go is back to Annex U. Purpose of these controls is to reduce the likelihood of an incident occurring or to mitigate the severity of consequence of an incident occurs. No control is infallible, and that's correct. All of the controls are subject to errors in human performance, whether at the design. If you're not looking at human performance in the design areas, you're missing the boat. There are opportunities. So it's something to think about without question. With me, I'm a 6 why guy. Somebody tells me why something happened, I say, well, why is that? You just get a little different answer. Well, why? If you ask why 5 or 6 times, kind of a 6 Sigma thing, you will find that often things were missed at the beginning. Same thing, you can go through this if you care to. Principles of human performance. People are fallible, error likely situations, and it's not just workers. Workers make human performance issues. Supervisors, managers, VPs, and CEOs, we all make human performance issues, and design is where you can really mitigate some of these human performance errors, in my opinion. A couple of things I want to go through then. Reviews of serious injury, and this is from the ASSE.org, Serious Injuries, Fred A. Manuel, fabulous guy. Reviews of serious injuries or fatalities involving exposure to electric current indicate that while lockout-tagout systems may have met OSHA and National Electrical Code requirements, the design of the systems produced error-inducing situations, i.e. lockout stations were not conveniently located. And this is in the December 2008 Professional Safety ASSE magazine. Fred also says, hazards and risks were not adequately addressed during the design process. That one portion of this sentence almost sums up this whole webinar in my opinion. And inadequate design features often appeared as causal factors in incident investigation reports. After you do the incident investigation, you'll find the design was poor. So think about getting it right from square one. You have to read this book if you're into this, into the safety world at all. Advanced Safety Management by Fred A. Manuel, simply the very best book out there, so highly recommend it. And I've also got a couple slides from, it's the American Journal of Industrial Medicine from 2014. It was called Occupational Fatality Risk in the United States and the United Kingdom. John Menilov, PhD, and Laura Statsky. I'm not going to read all this stuff, but if you look down, what you're going to see are some of the codes. What was the event, the UK rate, and you're going to see the US rate, which is certainly the same as Canada. So contact with electricity or electrical discharge, the rate in the UK, 0.037. The rate in North America, 0.14. It's a huge difference. And you have, why is that? If you start thinking about root cause and ask why a few times. Well, and I've just taken some very small snippets out of this journal. It says, other UA member states have also lower fatality rates than the US. We saw that the UK rate had been about 1/3 of the US rate in recent years. Figure 3 in that paper shows the UK had the lowest standardized fatality rate in the EU in 2008. However, Finland, France, Sweden, and Germany all were no more than twice the UK rate. The implication is that they now have also have work fatality rates considerably lower than the US or North American rate. That should bother us over here. The EU Framework Directive of 1989, and this is key, requires firms to do things that are not required in the US or North America, and that's to carry out an assessment of the risks at their work sites and ensure that some safety expertise is available in the workplace. And that needs to be done in the design phase. Explanations for the reasons why the UK is substantially lower fatality rates in the US obviously need more attention. The objective of this paper, I highly recommend that you read it, the whole thing was to suggest the differences are large and the efforts to understand their causes would be very worthwhile. Our comparison of the reported work injury deaths in the US and UK indicate the workers are killed in a job at a much lower rate in the latter. It is highly significant that, and here we go, it is highly significant that the EU declared that risk assessment is the cornerstone of the European approach to prevent occupational accidents and ill health. That statement is foundational and should be supported by safety professionals. We need to start doing that in North America at a much better rate. And risk assessment as that cornerstone, if the risk assessment process, the start of health and safety management approach, back to CSA Z1000 or 18001, is not well done or not done at all, the appropriate preventive measures are likely to be identified or put in place, and that's correct. Electrical safety management, a best in class. So we're really good at work procedures here in North America. That could be 70E on this side as well on the top left. In Europe, they really focus on design in the risk assessment phase, and it has had major impact. Very quickly, a real good friend of mine at a major corporation, and this I've just taken the names out of it, but this is an email, just the one page. In April 2000, two of my good friends and colleagues, they flew to the UK to meet three of their safety leaders from one of the very best leading corporations, two from the UK, one from the Netherlands. Their mission at that time was to map out electrical safety management system that brought together the best practices from Europe and the US. The UK and the Netherlands colleagues were experienced in risk-based approach, which we just saw from the papers, but wanted to incorporate the safe work practices and PPE concepts common in US and North America, which we're really good at here. My two colleagues were the very best in regards to North American concepts and were grounded in the 70E or certainly Z462 emphasis on safe work practice and PPE, and they wanted to add the UK and European approach. Brilliant. Benchmark the best. They spent a week mapping out what became their electrical safety management system, which was completed and implemented in 2003, and they have seen extraordinary results. They have the best electrical safety program anywhere because they benchmarked, they did risk assessment, and they put it in at the design phase of their electrical safety management system. So it's not about electrical safety, it's about electrical safety management. That's where the rubber hits the road. What do we talk about today as we're just winding down? Short introduction, give you a little overview of the CSA standards in regards to why they're so nicely aligned. We're the only country in the world where all our standards are aligned so beautifully. The importance of CSA Z1002, risk-based standard, and why we implemented it as a best practice into CSA Z462, so they're so nicely aligned. And how does that risk assessment alignment, how does it go back into the design phase? And it's always about the design. How can you do it right the first time? And then the alignment of Z462, we looked at Annex O, the design, the human performance. So we could do a big webinar on human performance. It's a very important thing. And at the end of the day, you've got to get your ROI. What's your return on investment for safety of personnel and to continue to be a profitable business? That's where it's at. We know that in Z462, they have shock risk assessment procedures, and they're very good. We know that there's arc flash risk assessment procedures in Z462, two different methods, table method or incident energy analysis method. What I'm suggesting to you today as a summary is we need to have risk assessment procedure in the design phase. Go and get the very best equipment. Think about what it is that you're doing in an initial design or a retrofit, and go and seek out the very best people. That design, all those things, it's just part of a good job plan and being profitable. Thank you very much. I do really appreciate the time to go through this with you today. And if you have any questions of myself, sir, we're going to take a few questions now. If you have any questions of me that we can't get done today, there's my contact information. Certainly i-Gard, they are world-class experts in high resistance grounding, and I can tell you that they also are very, very committed to electrical safety. They are very involved with our IEEE gang. So it's one of the reasons we had an opportunity to link up with them today. And I'd like to thank Electrical Business Magazine for the opportunity to speak to you. Thank you.
Hello again, Mike. That was fantastic. Excellent presentation, as usual, and it's really nice how you connected all those dots between the various standards and the best practices. Now, to our audience, now is the opportunity you have to ask any questions of Mike. Again, it's probably easiest if you type those questions into the question window in your navigation pane, not chat because it'll go out to everyone, but use the questions window in your webinar control panel. We have a few minutes for questions. Now, Mike, I do have one that came in a little earlier on. I think it was during that slide when you were talking about Europe and how they're doing better on the electric front.
Sure.
How they're a little more advanced than USA and Canada. Now, you've shown some numbers, but now are there any differences between these jurisdictions in terms of how they deal with electrical workplace fatalities in terms of consequences or follow-up by various ministries, government jurisdictions, penalties, anything you can speak to there?
It's certainly not something that I have looked at too closely, although just occasionally in the last 2-3 years, I know that in the UK, apparently they just have some terrible consequences for businesses that don't comply. So, and as always, even here in North America, sometimes there can be workplace fatalities, and quite frankly, you have to wonder if the consequences are all that high. So I truly don't know. To be sure, it's a very good question, and I think rather than focus on really hammering someone after an event, it makes far more sense to me to do what they're doing, which is to focus on risk assessment and have less incidents to even deal with. So.
Very good, very good. One question here that's come in is, now did you say that in future versions of the CSA standard, I'm assuming Z462 standard, facility owners will be required to conduct a risk assessment prior to an electrical upgrade? And if not Z462, which standard would this be specified in?
Well, it's very important to understand that CSA Z462 is not the law, and it is not it's not mandatory, quite frankly. I describe it as a due diligence standard. If you're in Ontario, you got to follow the health and safety legislation in the province of Ontario. If you're in Manitoba, BC, there are, and in Ontario, for instance, just stay here for it says, don't get shocked and don't get burned is what it says. And if you have, you're going to have to deal, with the MOL in the province of Ontario or the CSST in Quebec or whatever. But it suggests strongly as due diligence that you might want to. You'll see the words, and I whip through them pretty quickly, but shall is a very strong word. What you'll see, and if you read Annex O, I highly recommend you go and read it carefully. It says should. There's a difference between should and shall. And also, any of the annexes in Z462, you'll see that they're non-mandatory. So they're even a little less rigor than there is in the body of the standard. And even in the body of the standard, it is not the law. If you ended up in a court of law and someone says, do you follow Z462? To your due diligence and doing everything reasonable, it is probably very reasonable that you would follow a due diligence standard, but it's not the law. So definitions and words are very important.
Yes, that is very tricky, isn't it? Just the difference between should and shall. I have another question here, and you had delved into this in one of your slides as well too. In terms of Z462 suggesting to us that those responsible facilities and the people working in their facilities where electrical energy is a potential hazard, they should do a hazard risk assessment. And then it also goes on to suggest a method or methods for reducing that energy hazard and implementing them. Now, can you speak anything to just the consequences, I mean, to body and person, but also to property. You had mentioned, if you had to go to court and proving due diligence, what are the consequences if you don't take a look at electrical safety in the design phase and basically you're chasing safety afterward? How could you essentially set yourself up for a fall?
I think what's really important is, things have changed. We were very lucky, and when I was still in a power plant, we jumped right into this whole thing in 1999. So I've been at it for a long time. Was the electrical safety program coordinator. We put all kinds of things in place, and we had the time and the ability to do it. A lot of places are just finding out recently, or maybe even 6-7 years ago, but it's very hard to retrofit your PPE. It's very hard to retrofit your equipment, and when you need to, you really truly do need to look at best practices. So I don't know if that's a very good answer, but it's just about whoever owns your facility wants to get the maximum benefit out of their facility, and you want to be able to push it hard and not have shutdowns. If some places are going to have one lineup of 4160, 1380, 600 volt switchgear, and if it goes down, their plant is down. In the big power plants, we had odd and even buses, and we could switch and we could keep power flowing to the public. But you really need to look at your design for short circuit coordination studies and really spend a little time, spend a little money at the beginning, and it will be money well spent for many, many years.
Very good, very good. So I just have a few closing comments here in case one final question comes in. We'll get to it. But meantime, Mike, again, I want to thank you for delivering this presentation, and I want to thank everybody out there for attending. Now, you will be receiving a survey afterward. It's not huge. Maybe take about 60 seconds. Let us know what you thought of the presentation, and of course, feel free to suggest future topics that we at Electrical Business should be covering. Of course, I don't want to be remiss. I want to thank our sponsor, i-Gard. That's i-Gard.com. For sponsoring Mike and sponsoring this webinar. They are the electrical safety pros, especially when it comes to high resistance grounding. So do please give them a look, give them a shout, and find out how they can help you create an inherently safer workplace. I also want to mention that i-Gard is a sponsor of our second annual Electrical Safety Champion Awards. Now, if you haven't had an opportunity to check that out, please do. The deadline for nominations, and it's a very simple process, the deadline for nominations is this Friday, so only 2 days away. And a big thanks to i-Gard for sponsoring that as well, too. There's no question that they are the thought leaders and promoters of electrical safety. They themselves are champions for doing that. To get involved in the Electrical Safety Champion Awards program, visit our website, ebmag.com/ESCA, standing for Electrical Safety Champion Awards. That's /ESCA. So if there are no other questions, we'll wrap it up there. There will be the survey. And I thank all of you for attending. Mike, again, thanks to you, and thanks again to i-Gard. Everybody have a safe day. Thank you.